last years of the 19th century, that human affairs were being watched from the timeless worlds of space. No one could have dreamed we were being scrutinized as someone with a microscope studies creatures that swarm and multiply in a drop of water. Few men even considered the possibility of life on other planets. And yet, across the gulf of space, minds immeasurably superior to ours regarded this Earth with envious eyes. And slowly and surely, they drew their plans against us.
Broadcasting live
from a tiny studio somewhere in North America.
This is Dark Matters Radio Live. And now I give you your host,
the silverback of ufology.
Here's Don Ecker.
And welcome all once again, another brand new edition, Dark Matters Radio. You know, since the beginning of July of this year, we have had something that has impacted the UFO UAP field like nothing I have seen in quite a while. And that, of course, is that, I guess you could say, mysterious object, 3I Atlas. What the hell is it? Well, if you ask most astronomers, they're going to tell you it's simply a cometary object. A little strange, granted, did some off-the-wall things, but it's a comet. But if you go on the internet, I have never seen so much bullshit about something in my life, well, for years anyway, as I've seen about 3I Atlas. To me, that proves one thing, that the critical thinking in this field, and if you get right down to it, most everywhere else, my God, it's dissipated, it's gone away. Critical thinking, common sense are items that, well, they're not very common anymore. So anyway, why do I even bring this up tonight? Well, in just a couple of weeks, this object, 3I Atlas, is supposed to make its closest approach to our little blue planet, planet Earth. Now, when I say its closest approach, I'm not talking about right next door, okay? Well over 100 million kilometers away. And if I'm wrong, well, tonight's guest will correct me. And who is tonight's guest? Well, our favorite astronomy nerd, Mr. Marc Dantonio, who, by the way, has his very own program right here on KGRAdb. Now, tonight, as always, my compadre, mi amigo, Mark Center is here. However, although he didn't contact me, the guy that this show is basically assigned to, Mark tells me he got an email from Gerry saying that he didn't have any internet tonight. Mark, begs the question, if he doesn't have any internet, how the hell did he contact you?
And there's a cross-pollination between Wi-Fi, cell phones, internet, and hookers on your main street. So.
Oh, okay.
Yeah.
Gotcha, buddy, gotcha. Well, with that being said, let's get our guest up here, Mr. Marc Dantonio.
I'm in the wrong show, man.
Mark, Welcome back.
I'm in the wrong show for this is like you talking about hookers. I'm in the wrong place. Let me get out.
That's right. How many times have I had you on my show?
A lot of them.
How many times have I been on your show?
Oh, I don't have guests, so that's not fair.
There you go. There you go.
If I had guests on, you would have been the first, but I don't have guests on my show. I don't.
I'm screwing with you, dude. I'm just screwing with you.
But no, it's true though. I mean, I my show is not a show where I interview guests. My show is a show where I basically.
But you could if you wanted to.
It's an education show. Come on.
I could.
It's education.
It all depends on what you want to do. Come on.
Yes.
It all depends on what you want to do.
Yeah.
Hey, Don. Before we start
thing.
the show, I found some archival footage of you. Probably late 50s, early 60s. I'm not 100% sure. I sent it to Skywatcher. Skywatcher, would you bring up the footage that I found of Big Don Ecker?
A bullshit? A bullshit? A bullshit. A bullshit.
Here's to you, Don.
Well, he's got it down pat, though.
From right out of the chute. Right out of the chute. Don was already calling strikes and balls.
Mostly balls.
Yes.
Well, guys, here we are as we do the show today. Oh, which reminds me, and I wanted to mention this. If you are on Facebook, okay, go to my private Facebook account. Not the DMR account, but the Don Ecker account. I reposted a post I put up in 2011 about a trip that I made to Roswell, New Mexico. The write-up will explain the whole thing to you, but there I found an actual witness and participant to the Roswell crash event, whatever that was, and it is some fascinating information. This is a bit of Roswell history and trivia that very few people are aware of. The man's name was Mr. Thomas Gonzalez. Thomas was a member of T Squadron in the 509th Bomb Group, 509th being the very people that ended World War II by dropping 2 atomic weapons on the Japanese in Hiroshima and Nagasaki. They were the people at the time stationed out at the Roswell Army Air Base where this situation took place. And I think you'll find that that posting I put up to be of interest to you all. Now, like I said, it originally went up in 2011. That's a long time ago. So maybe it's time to go back. If you haven't seen it, check it out. And if you have, maybe reread it. Okay, that was said. Marc Dantonio.
Sir, yes,
Have
sir.
you ever in your life seen as much hoopla and foofra as we've seen with 3-Eye Atlas?
Yes. Oh, you want me to elaborate?
You're just a contrary SOB, aren't you?
No. Yeah, and everybody else will know this too. Is when I say it, they're gonna say, "Oh yeah, of course." The moon landings, Don.
Okay, but I'm not talking about moon landings.
Well, I know we're talking
right,
about
but not as it was going on. This is different. This is happening as it's unfolding in front of our eyes.
That's a good point. What he said is a good point.
Thank you very much.
It's a very good point. Yes, you're right. During this, now the reason it happened is because of one astrophysicist named Avi Loeb, who first said that Oumuamua may have been a alien spacecraft in terms of a design like a solar sail that came through our solar system. Now, it wasn't seen until it was already on its way out. So it already went through, came through, and then on its way out, when it was out here, that's when we first saw it. So we didn't get a good look at it. We also didn't have
But wait a minute, Mark. There was some strangeness about that. Because on its way out, did Oumuamua not suddenly speed up?
It did show a change in its trajectory that was unexplainable by a simple ballistic motion and gravitational acceleration. You know, that was what that means is, yes, it did something a little quirky as it left. Now, what could that have been? Well, first of all, the press got Oumuamua all wrong. Okay, let's stick with that. Now, that's one eye. First, interstellar. The eye is interstellar. One eye, Oumuamua. Okay. The press called it a narrow spindle like a needle. They said it was 700 feet long and 70 feet wide. Well, they got that unbelievably wrong. That's not at all what Oumuamua looked like. It was discovered later that Oumuamua was more like a pancake. It might have been thin in cross-section, but it was large in diameter, okay? And if you put it on its side, maybe it was 700 or so feet long, but turn it sideways, and it was also, hundreds of feet in diameter as well. So it was more like a pancake, kind of like what the Event Horizon craft found when it went out past Pluto and went to the Kuiper Belt and visited that first ever Kuiper Belt object with a human-made satellite. And that was the called contact asteroid, a binary asteroid called Ultima Thule. Thule is pronounced Thule. So Ultima Thule was a pancake, but it was two pancakes, but they were end to end, and they kind of froze this way. Now, when something collides in space, the ice, it made mostly of ice is way out there. When they collide, there's an instantaneous melting at the joint where they collide. When that happens, it almost instantly refreezes, and now they're bonded forever until something else strikes them and takes them apart. So that's how that reached that configuration. So Ultima Thule stands as an example of a pancake object that was kind of like Oumuamua. So if Oumuamua was traveling through our solar system like this, and then as it left the sun, it rolled and now had a whole planar side facing the sun, that could have caused it to accelerate in a different way that was unexpected.
Could have.
Could have. Oh,
not
I'm not
not
saying
necessarily would have.
No,
let's be specific.
Yeah, no, I always said it could have. I'm not saying it did. I'm just saying, but that could explain it. Now with 2I Borisov was a comet that came and went, and that was a true comet, and that was interstellar. Gennady Borisov, an amateur, he actually found this comet and got an interstellar object named after him. So he will go down in history as an amateur who discovered an interstellar object, which is kind of cool. And now come along with 3I Atlas. Now, by this point, when we see Oumuamua, we're surprised. And people are like, hey, we should have known that was coming because we didn't see it till it was going out of the solar system. That was a planet killer if it hit us at that speed. So then they decided to start putting together a network. Well, Borisov came and went, and now we have a network of telescopes that are more cohesive and more in communication with each other, and that's called the Atlas system, and it's ATLAS. And it's like the asteroid and terrestrial alert, last alert system, something like that. And what they do is there's 3 main telescope stations right now, okay? And they're adding a 4th one, I think, in Spain. And what they do is they just scan the skies for near-Earth objects, all right, that may pose a danger. And so Atlas is proving fruitful. So 3I was found by the Atlas telescope systems.
Well, from your perspective, Mark, Oumuamua, Borisov, and 3I Atlas cannot be the only interstellar objects that have entered our solar system.
That's correct.
Okay.
That's correct. Yeah. And who knows? Maybe life on Earth was seeded by an interstellar object at some point. Who knows?
But now we are much more aware. Is that correct?
we have a better awareness. We don't have a way to counter it if it's heading for Earth. But we do have, and we did do tests with the asteroids to show that we can deflect an incoming asteroid successfully. In fact, it was better than expected, and that was with the Dimorphos and Didymos collision, the dual asteroid rendezvous DART project, where they collided a impactor, a kinetic projectile, with the smaller of the two asteroids. They're binary asteroids going around each other. And the reason that it's good to hit one of those is because if the orbit changes even a little bit, we can tell. And it did by a lot more than we thought. So the impactor struck the smaller of the two on purpose, and it changed its orbit. That
had to be some tremendous engineering. My God.
Can you imagine that? I'll tell you a little story. The first person to arrange a probe landing on Eros was during the near-Earth asteroid rendezvous, NEAR. Okay, and that person that was in the team presiding over the landing was a Catholic nun by the name of Mary Ellen Murphy, who sat right here in my house, up at the table, right about that direction. And little white-haired old lady, sweetest lady, didn't let on anything about her background. And she asked me to show her some Hubble photos. So I brought some Hubble photos up. I printed them out in color for her. And here I am describing them to her, saying, oh, yeah, this is a planetary nebula. This green is from a doubly ionized oxygen causing this bluish green color, and the red is hydrogen gas, blah, blah, blah. I explained a little bit of the physics to her at a level that I think a white-haired older person would understand, right? And meanwhile, the other Catholic nun sitting at my table, who they're actually, that one was a family member, okay, she starts laughing at me. I go, Florence, what are you laughing at? Was her name. And she goes, she's an astrophysicist. But what? I was like, I was blown away. And she said, and then it was Florence that had to tell me, oh yeah, she was on the near-Earth asteroid rendezvous system, and she helped land that probe on Eros, the asteroid. I went, I'm not worthy. Okay, it was incredible, so I had what I considered royalty at my table, and she never let on that she worked at Goddard Space Flight Center. Never told me. So I thought that was just hilarious. So I always welcome such interesting things, So the near-Earth asteroid rendezvous system showed us that we can actually land on an asteroid safely. We then went on with the OSIRIS-REx probe, okay, and landed on Bennu, and retrieved a piece of Bennu and brought it back. Now, Bennu is a different asteroid than Eros. Eros is sort of a rocky asteroid, covered with lots of dust. Bennu is more like a rubble pile held together by mutual gravitational attraction. So if we exploded a nuke on Bennu, it might just shatter into billions and billions of tiny particles, because that's all it is, and they're just held together by their own mutual gravity. So it's not really a surface per se. It's kind of like a mass that if you pushed it, it could just probably just go blah, 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 and do that for a long time.
How large is it?
Bennu is actually relatively small. I don't remember the exact size, but if I recall, it's only a few kilometers in size. It's not large, but it was big enough for us to land on and retrieve something from and bring those samples back. Now, that was OSIRIS-REx. Now, incidentally, Mary Ellen passed away a few years ago, and the OSIRIS-REx team said, hey, do you have anything that you might want to, put on the OSIRIS-REx probe? And I went, oh, I do indeed. So I got all kinds of pictures of Mary Ellen Murphy, and I gave them to the team, and they got back to me and said, she's on the probe. We put a microdot on it. So she's gone to space, and she's going to orbit the sun for billions of years. So I thought that was kind of cool. Well, anyway.
Well, I'll tell you what. When you talk about people going to space,
yep.
Now, this is in the same city, but it's on the way far side of town. You know what I'm talking about in a second. But who would have ever believed back in 1967, 68, or 69 that Captain Kirk, William Shatner, would have launched into space at 90 freaking years old?
The Shat.
And that's why they call him that. After the launch, he had a good time up there. Yeah, I thought that was pretty cool. What I didn't appreciate was Jeff Bezos, when he came back down to the ground, was trying to talk to William Shatner or talking about what he felt. And Shatner started telling him how he felt, and he basically turned away from him and walked away. He basically almost like snubbed him or something.
Are you saying he shat all over him?
He did. Okay. Yeah. I didn't like that part. But, yeah. And the Shat is actually someone I've actually worked on his show. I did The Unexplained with William Shatner at one point. And I asked them if I could do my imitation of William Shatner on the set. And they said, probably best if you don't. And I went, I won't do it. It's okay. But anyway, well, I saw William Shatner at a local college here, and he was doing his Shakespeare stuff. And my dad brought me because I was a young kid. And as we went out the back door, we walked by the stage door, and Shatner comes barreling out of the door. The door flies open, hits my father in the face, and knocks my father on his butt. Okay, and William Shatner goes, "Oh my God, I am so sorry." And he picks up my dad and brushes him off. And I'm going, now my dad, bloody nose. And I'm sitting there going, my dad got hit by William Shatner. This is so cool.
Captain Kirk, by God.
Well, I did say Captain Kirk. I said, Captain Kirk hit my dad. Captain Kirk hit my dad. I didn't even care that my dad got hit in the face by the door. And then Shatner sat in his purple Monte Carlo from New York. Okay, window down, arm on the side, and my dad's leaning down talking to him like they're best buddies. And Bill says to him, Leo, I hope you're okay. And my dad says, "Oh, I'll be fine. Don't worry, Mr. Shatner. Call me Bill. Call me Bill." And it was like, "Oh, please invite us to your house." And it was Captain Kirk, and I was like, "Wow, Captain Kirk." Yeah, so that was kind of funny. But
so regarding the 1, 2, and 3 atlases, would it be a proper thing to say, and this is based on the images I sent you guys from that crazy Facebook page and blah, 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 that we don't know what we don't know? So because there's a lot of nickel, right, which is different, not unheard of, but it's different to have it a lot of nickel on something like this,
and very very little iron.
That's fine.
That was only initially. I'll talk about
right.
that.
We have no
You'll correct
clue.
me?
Yes. We have no clue that one may come through, who knows, with a lot of gold on it or a lot of lead on it or whatever, because we're seeing stuff we've never seen before, right? So I see these people freaking out about all of this, and I'm not saying that it's an inexplicable thing. It might be, but since we've only seen 3 of these things that were identified, they could be, I mean, it just makes zero sense to me that these proclamations are being made on such a short span of information.
But you're going to get that anywhere because we also have a social media that depends on clicks. Okay.
Right, but the smart guys, I mean, again, for Avi Loeb to invite a Kardashian into his team who doesn't believe we landed on the moon, and that's a known fact, I kind of understand the machinations around that. She's good looking and all that, but I kind of get it because maybe he's liking the attention or something like that. But I mean,
I can't speak to that honestly. I did send our esteemed producer Bill. I sent him my time lapse of 3i Atlas I shot the other night, and that's going to be in Teams. And he'll, now that he knows, if he's listening or not, he'll make it available to you. But
unless he's in the bathroom.
There's that. But here's the thing about the nickel you were mentioning. Okay.
Yeah.
Okay. When we first saw it, it didn't have just a lot of nickel. It had a real plentitude of carbon dioxide. Way more than comets normally have. Comets will have carbon dioxide. Okay. But this was an awful lot of carbon dioxide, meaning a lot of dry ice on the surface, basically carbon dioxide ice. Now, my thought was, Okay, it could be a comet that passed through a cloud. There was maybe been a specific, might have gone through a molecular cloud with a lot of CO2 in it. Okay, carbon dioxide is not uncommon. Oxygen is the third most abundant element in the whole universe. Carbon is the fourth. So, it stands to reason it might find something. It might find something there. Well, the nickel was puzzling at first. And later on, we started to see the iron and that nickel iron ratio, the Ni to Fe. Fe is iron in the periodic table. And the Ni/Fe ratio started to change. All right. And it started to even out a little bit as more iron was found. Okay. It went from a very large number because of a lot of nickel to a more reasonable number because there was a lot of iron coming into backfill. So, how come that happened? Well, it turned out that the nickel, all right, might have been bound up with another molecule of carbon monoxide. That's carbon and oxygen atoms, CO, right? We hate CO. CO is bad for us, right? But it's plentiful in comets, and there's plenty of it here in this comet.
Well, CO is great for plants.
And that's true. That's right. Okay. And so the nickel might have been, you might have had 4 carbon monoxide groups tied up to one nickel, and that makes what's called nickel carbonyl. Okay. Carbon YL, carbonyl. And the iron might have been bound up to 5 of carbon monoxide groups. So it'd be iron pentacarbonyl. Okay. Now, what's the difference? The difference is the vaporization states. When nickel carbonyl vaporizes, it'll vaporize, releasing the nickel atoms to be free at 100 degrees Fahrenheit. Okay. But the iron pentacarbonyl doesn't vaporize until 200 degrees Fahrenheit. So it's possible, not definite, but possible, that the iron pentacarbonyl took a little more time. So the comet had to get closer. And then as it did, we theorized maybe the pentacarbonyl vaporized and the iron was then freed. And we did indeed see that the nickel was joined by much more iron later as it got warmer. And so that's one of the theories and the possibilities, because we do know that there are carbonyl-like molecules on comets as well. Not these exact kind, though. So that's a mystery. Okay. But again, it is interstellar. It is interstellar.
So, what are the with the second atlas and the third, as far as what Avi Loeb was postulating?
Yep.
What are the crossovers between those? Because he gave a percentage to the second one that it could be built or of alien origin, plus he's done that for the third one. Are there crossovers between those two that he may have looked at and said, wow, there's reasons to believe the third one might be as well?
Well, the second one did different things than the third one. And the third one was much more interesting for the following reasons. Reasons plural. First, it came in parallel to our circular plane of our solar system. Okay. So our solar system is actually on an angle to the galactic plane. The galactic plane's like this, and our solar system's at a 62-degree angle to the galactic plane. Okay. So it's going around the galaxy like this. Okay. Now, the thing is, from the side, you can see how the comet could cross the plane of our solar system if it came from the galactic plane, which is where it came from, by going this way. And that's exactly what it did. All right. Now, that was very strange. The chances of that are lower. Okay. But the chances also of it passing 3 of our major planets in our solar system were even more low. The fact that it passed Mars, the fact that it passed Venus, and the fact that it's going to pass Jupiter in March. Now, still millions of miles away from each planet, but still passing those 3, the chances are like 0.005%, So that made it stand out as a potential intelligent craft. I get it. Actually, I commend Avi. You guys know that I've worked with him on a few things, and I commend him for the open-mindedness. Now, the other night, he released a video, and I'm not sure it was actual or AI, to be honest, because in it he said, Oumuamua has vanished. 3i Atlas has gone. It's not there. It has disappeared entirely from the sky. Like, whoa, really? Well, the following morning, I opened up our Benson Observatory with SkyTour live stream, and I imaged 3i Atlas once again. And there it was, as before, and I did a time lapse of it. Now, the producer has the time lapse, and he'll make it available to you. This is from earlier in the week, but it's the same. It did the same exact thing, and the new time lapse looks just like this one, just different stars in the background. All right, so it's still there. So I'm not sure what that was, and I'm wondering if maybe it was AI meant to sabotage Avi. Because what's funny is you find that people try to talk bad about academia because they're so stiff and regimented and don't have open minds. And now we have someone who is not stiff and not regimented and has an open mind, and they're trying to destroy him too, possibly. You can't have your cake and eat it too. Pick a side and stay there. Don't be jerks. I don't believe that it's
But that's the time we live in, Mark.
No kidding. I mean, I don't believe. In fact, in the very beginning, I noticed it was doing commentary things, and the more we saw about it, the more I realized there was commentary. Okay, and over like a comet means a comet, quacks like a duck. So it was giving off cyanogen. That was the green color, and in fact, in our time lapse, you'll see it's green. All right, and that's cyanogen. That's carbon compounds.
Can Skywatcher put that up?
He says he got there. It is. Okay, so now here's the time lapse. Okay, that's December 1st. That was
again, please.
Yeah, it's short. You should loop it. Okay.
Yeah, a week ago.
Yeah, but it looks the same from just 2 nights ago, two mornings ago. Okay, same exact thing. Doing the same exact thing.
So what approximately is the speed, Mark, of that thing?
Well, when it was, it's been a little faster going around the sun because the sun was tugging on it more. But as it leaves, it's probably going to leave with about the same speed it came in at, which is about 134,000 miles an hour. So not very fast.
No, that's relative.
Yeah, I know. And when it passes the Earth on December 19th, it's going to be a whole 720 times the distance of the moon from us. So absolutely no danger. 1.8 astronomical units. That's almost the distance to Mars from us. So honestly, this thing is, if it was an intelligent craft, they would have known that this planet is the one that's giving off intelligent signals. I know that's arguable. Okay, but they would know that this was the planet where that was happening. They would see the oxygen in our atmosphere. They know it's being replenished by something, and that something would generally be.
Well, for the sake of argument, let's say not living organisms, but artificial intelligence running it. Now that would put a little bit of a different spin on it, wouldn't it?
Well, maybe. But in that case, they might just say, well, if we hit the damn thing, we'll hit it, And they might say, oh, well, if we collide, we collide. They might not have that morality. Again, that's one of the big problems we have with people trying to decide how alien races would actually work, right? They assign our morality to them, like they're going to think the same way that we do. Okay? That's not necessarily true. Do dogs have the same exact emotions as humans? No, not at all. They have a very different mindset, much more shallow pool of emotions they draw from. Most of it from instinctual characteristics from deep instinctive evolutionary backgrounds. But humans are far more varied and far more flexible and do something very different from the animal kingdom. We can change our behaviors over time and see differences in our past behaviors and say, wow, I can't believe I did that. What a bad person I was to do that. But now I'm a better person. Animals don't do that. They don't reason about their past. They look only at the moment, as far as we can tell.
So one of the issues that Avi's got, and I'm sure he knows this, but he may not concern himself with it because he's got better things to do, is that he's coming out and saying these things in a time that we haven't seen possibly ever associated with this subject, and that's Congress, Grouch. All of this stuff is exploding. And then he comes out and he says this wouldn't have had this type of public response even in the 90s. It would have gotten some articles and stuff, but it wouldn't have had this kind of response because we're polluted with this stuff now. So here comes a super smart guy to say this and put a percentage on his prediction, and then people just glom onto it and say yes, 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 from both sides of the camp, right?
That's right.
You know, you know the guy, and he may be one of those guys who's just so busy and stuff, he doesn't care about any of that. It's all social noise, right? So he just says what he says based on his beliefs and his education.
Yeah, that's true. I mean, I think that his approach is one where he's done the hard research. You know, I saw him explode at some journalists and really sound off because they were trying to imply that the internet was saying this and what you're saying, you know, isn't exactly the right thing. And then he exploded and said, I'm the one doing the research. I've written 9 papers to date, now 10, 9 papers to date, peer-reviewed papers on this. So I'm doing the research, okay? You're a journalist, and I'm the guy doing the research. And he's not wrong about that. And that, for that part, you know, is, even though that came off a bit gruff toward the journalist, I was okay with that because I understood where he's coming from. However, with another journalist, he did the same thing, but the other journalist wasn't going down that path. He was giving him that respect, but he took it the wrong. Avi took it the wrong way, I think, and so he sounded off at him as well. So I think it's best if he just sits back for a while and doesn't engage in this.
Yeah, that's what that's who was that? Don might have said it. He said, we're all going to feel pretty stupid if on the 19th it makes a hard right turn and comes in for a landing. Granted, so let's wait and see.
Yeah. I know that he was talking about the anti-tail and thinking of it as a potential exhaust. But I didn't see it that way either. The anti-tail of a comet is very common sometimes.
Yeah.
Right. I think on the program with you last time I showed it to you.
Yep.
An anti-tail on one of the comets, Susan Chen Atlas, another one found by the Atlas team. I photographed that one. And when I photographed that one, it had an anti-tail. And you saw the tail streaming to the right and the regular dust tail streaming to the left. So, again, that's a perspective thing of the tail swinging around as the comet turns in its orbit like this. Okay. You see the tail behind it. And as the comet's coming toward us, sometimes that faraway tail looks like it's in front of the comet out here.
Right.
But it's way out here. Okay. And if you turn it sideways, you see that tail is way far away. But from the perspective looking directly at it, this looks like it's in front of the comet. Okay. And that's how an anti-tail works. So again, one of the problems people have is they don't fully understand the 3-dimensionality of the universe. And it's hard to do spatial relationships when you're looking at a 2-dimensional sky.
I think the best example you gave us was when the Voyager or whatever went through the rings and it didn't even get close to hitting any of that. Now, me, as a high school guy, and I'd see the photos and all that, I would think there's no way you're going to fly through that. You're just going to get pummeled.
That's the Cassini orbiter, right?
Right. It's just not the case. There's so much room.
I think they flew through it twice.
Right.
And they were getting some data on the ring structure. Incidentally, with Saturn, just a little sidebar. Let me move over for that. Yeah. Okay. Here on the side, one little thing that's interesting is Saturn's rings are evaporating. They're not going to be there forever, just for the record. It's actually falling into the center of the planet. Little by little, those rings are going to get thinner and thinner and fainter until there's none left. But that's maybe a few million years from now. But
well, supposedly Earth also at one point had rings.
We did, probably when the moon was first created. That's right.
Right.
Yeah, and
Right.
then over time, the moon congealed, and all the impacts on the moon led to a lot of the impacts on the Earth. We had a late bombardment era, billions of years ago, where more stuff hit the moon, more stuff hit the Earth, and made both the moon and the Earth molten again. So it's pretty interesting how that all works out.
Hey Don, is that my Christmas present that's being wrapped in the back there?
I heard that.
No. Yeah.
The aluminum foil being prepared for dinner.
Oh, my wife, she loves to come out here when we're doing the show and get her dinner ready. So
yes,
it's just something that there it is.
And
deal with it.
The perspective thing, I brought this up last time, and I think about this like I get up like dawn. I get up fairly early in the morning. I go out. I do security checks, in the morning and at night. And I always look up and I check it out. And when I think about nearly 10,000 Starlink satellites, just Starlink, okay, I don't know how many more are up there, but there's 100,000 or whatever. For our little brains and mine, I think about the freeway in LA the day before Thanksgiving, freaking packed with thousands of cars. And in my head, I say, let's bring those up now and put those in the sky of what I can see, right? It would be polluted with VW bugs, right? But in reality, much like the rings, if it goes around the entire Earth, nothing.
I'll never forget the day that Mark Center called me.
Don!
In the evening, okay? Which, if we talk, it's generally morning or early afternoon.
Your first Starlink train?
Yes.
He was freaked. You're not going to believe what I just saw.
Intelligence! I tell you, it was intelligence.
It was.
Yes. Just not the type I was looking for.
My first Starlink train was great. I went out there with my night vision system and recorded 25 of them. It was about day 2 or 3 as they started to separate. And so you could see like 5 or 6 at any one time out of like 75. And they would come in, they'd fade in and then fade out. And we had 5 or 6 visible at any one time sliding through. And it's just amazing. In that comet time lapse that we did, you saw one Starlink satellite go through. That's one of the star trails that you saw, and the trails in there was
oh man, I was hoping that was a UFO. Damn.
Well, it wasn't until you know what Starlink satellite in particular it was. Right?
Yeah.
Right. And I got my big screen, and there's a window there, and it's going towards the ocean. And as the sun's going down, it's pretty dark, but as the sun's going down, routinely I see interesting glowing things out there. Now I know that it's more than likely what the pilots see and what they've been misidentifying until they got educated on this thing. But almost nightly now I look out there and I go, wow, there's another one. If I didn't know, I'd be Dave Aaron. I'd be freaking out, running around, taking shots. Hey, Fox, I got stuff. Give me it. I need to be on your next show.
Now you know how my life goes because I get a lot of those people.
I'm sure you do.
Do send those things. Well, let me explain. That's a good point. Pilots. Okay, you're at 37,000 feet flying along, and you're flying. Now your point of view as you get higher in the sky, you see further around the curve of the Earth. Okay, and so you're.
No, wait a minute. Mark told me the Earth's flat.
That's right.
Okay. Well, then I'm on the wrong show.
The firmament.
But as you look further around the curve of the Earth, you're also seeing satellites that might be coming towards you. And as they're coming towards you, they look like this. Okay, as you see my finger, I'm moving away, but you can't really tell.
Right.
Okay. Now, if you get over you, when it goes over you, they go like this. They travel right over you. But as they curve away from you, okay, they look like they're stopped. And then they kind of sort of gently fade out, and you might see several of them bunching up and coming towards you like that. Well, that process is what you see when you have an extended horizon from high altitude. So pilots have sent videos of a cluster of lights that they can't identify, that don't show up on radar naturally,
Right. That
and
split open.
and come toward you and go apart, come back together. And it's like, what are those? Well, that's what happens when you're looking around the curve of the Earth from the altitude you're at and seeing satellites in orbit coming at you at that certain point. They're coming sort of towards you, and you're not seeing the divergence very well yet because they haven't gotten close enough. But then they divert,
Right.
And so they mistake them for that. Now, you might say, well, pilots should be the best observers in the world. Yeah, they're
For
trained to
certain things.
for other aircraft. Yeah,
Yeah.
exactly. If you look at your window frame and you have a bright light flashing with FAA standard lighting and it's not moving in your windscreen, it's at the same spot, it's coming right at you.
Right.
That's called a collision course because you got the convergent path. And so it's going to look like it's in the same spot in your window screen. So that's what they're looking for. If it moves even the slightest bit, it's not going to hit you.
So I don't know much about satellites. I know they're up there. I believe in satellites.
Good, very good. That's a very good
And is there, when they put them up there, let's just go with the Starlinks, 10,000 of them things. When they put them up there, is there a satellite superhighway? They're all going the same direction. They're not going this. Does something keep them from colliding into not only themselves, but other things that are up there? It seems like quite an engineering feat to me.
It is quite an engineering feat. It is not a satellite superhighway. They're all in many times different orbits. Each flight of satellites is at slightly different positions, so they'll never bump into each other and smash into each other.
We hope.
Well, it's happened actually already. They're not with Starlink, but with a Chinese satellite collided with, I think, one of ours, and now there's like 330 million little pieces of stuff floating around in orbit in that particular vicinity, but that stuff's going to eventually drift down and burn up. So some people will be treated to a nice little meteor shower. But the fact is that the satellites in orbit are on very mathematically precise paths. But they have to have a way to correct their path. And the reason is because at that altitude, okay, like the space station's at 252 miles up, okay, they're not in the atmosphere. But if the sun is active, it causes the atmosphere to expand. And so a few more molecules than normal will be striking the space station. And that over time degrades it and it starts to fall out of orbit a little bit. So they got to boost it back up. Okay. So they have to have a way to kind of boost the station up with little burns a little bit at a time. And that's what they do. If they run out of fuel, then it will eventually come into the atmosphere and crash.
Right.
Even though
is there any way to refuel it, Mark?
Yeah. The progress rockets could bring up new fuel and stuff like that. In fact, that's what they've been doing. They've been refueling it over time. I'm not exactly sure how many times they've had to refuel, but they do. The James Webb has fuel on board as well, because the James Webb has to kind of hold station. Now, the James Webb is at what we call a kind of like a parking spot in space. Okay, it's at a Lagrange point. Now, when you add up all the components of gravity, okay, and you guys I think know this, when you add up all the components of gravity out of the James Webb, okay, the gravitational forces on it from all sides almost sum to zero. So it kind of, gets tugged a little this way, but a little that way, and kind of sticks around in one spot. But it's not exact because the planets do move. All right, the asteroids do move. So there's a little bit of fuel on board, and it actually moves in this really strange, kind of like a figure 8 type orbit or so. And it maintains that orbit using fuel. So once the fuel runs out, the James Webb will basically fall out of the Lagrange point eventually. So on the NASA docket, for instance, they have a refueling mission package that they want to put out there so they can get out to the James Webb Space Telescope 1 million miles away from us. That's where it is. It's 1 million miles away, well past the moon by almost 5 times. So it's far, far away. And so we're talking about having a robotic methodology to refuel the James Webb to keep it up there longer. Because, it has, I think, a 10-year lifespan. What that means is 10 years of fuel, effectively, when they say that, to keep it stationed. Now it has the ability to move, like were using electrical spinning weighted wheels. Like on Kepler, there were 4 weighted wheels that were spinning at different rates and changing direction, and that caused torques to actually move the satellite around. And they're very, very precise. Okay, they're called reaction wheels. Okay, I've got a picture of myself with reaction wheels for one of the Google Earth satellites, because I was in the high bay while one of them was being built out of Gilbert, Arizona. And I took a picture of it, and the reaction wheels are about this big around. Okay, and there's 1, 2, 3, 4 of these, and the system can run with 3 working reaction wheels. The 4th one is redundant. Well, when the Kepler Space Telescope went up there, it lost 2 of them, and now it was losing an axis of control. So what they did in this particular case with Kepler, they recalibrated from for the 2 remaining reaction wheels that worked. They recalibrated it to work with the sun's impact energy on the satellite, and they calibrated the other wheels to work with it. It wasn't perfect, but they had that 3rd axis back, because this was a constant force from the sun hitting it. And so they balanced that constant force with the other wheels and figured out the mathematics to make the Kepler steerable again. And that gave us access to the follow-on mission to the Kepler, which was K2, Kepler 2. And that found thousands more planets after that. So you see, we do have the ability to take care of things that are so distant we can't ever get to them again, like the James Webb. But we're trying to figure out ways. And one of the problems that we do have, going all the way back to 3I Atlas, is we have to have a way of diverting, say, a killer asteroid. Because whereas a small 10-foot asteroid, 25-foot, 30-foot, 100-foot asteroid might be a city killer, we don't want a planet killer. And we don't want a city killer to strike either. So we have to have a way of diverting them. So the DART mission with Didymos and Dimorphos, where they actually moved the orbit of that smaller asteroid, was really phenomenal. It showed we can do it with just a kinetic impactor. Bang, and push it away.
I have a question, Mark, about something dealing with Mars. Okay.
Yeah.
Now, since the 17th century, we, the human species, our astronomers have had fairly decent equipment considering the time frame back then, correct?
Yeah.
Okay. And one question has stuck in my mind for, 50 or more years. Mars has 2 moons in retrograde orbits. That in itself is pretty weird. But even though astronomers in the 18th, especially in the 19th century, should have been able to observe Mars' 2 moons, they were never discovered until 1877. Now that's weird, right?
Why?
I think it's very weird.
Why is that?
Now, I've read speculation about what might have caused that. One of the speculations, right out of science fiction, okay, that around that time period in the 1870s, those 2 objects were placed in retrograde motion around Mars by something else. Now, I've got a lot of respect for you,
What
for your discipline.
What are you, out of
Hey,
your
I'm
mind?
trying to be goddamn nice, all right? But anyway, how do you handle that from your perspective as an astronomer?
I would say that it goes like this. Phobos and Deimos on Mars are really, really small moons. I think Phobos is like 14 miles across, and Deimos is only like 7.5 miles across. So I'm trying to remember. But those are very small. So it stands to reason that without advanced systems, we're not going to see them. Okay. So not finding them until more recently makes perfect sense to me. Because they're going to be very, very small. You're not going to see them when they pass in front of Mars, especially with the telescopes at the time. We didn't have that capability to see something like that passing in front, because we would only ever see it as a star, but it'd be so faint that the telescopes at the time probably couldn't see it with the films they were using. They were using film to capture stuff back then, and Mars was so bright they didn't actually take photos for very long. They wanted to catch the surface, so they would be photographing the surface of Mars, and as such that means they would never see the moons, because they'd have to really overexpose Mars really badly to see any moons. And they might not have ever done that. I don't know. Maybe the thought never occurred. Maybe they did do it but never saw them anyway. Again, 14 miles and 7.5 miles or so in size, that's a small pair of moons. And from almost 2 astronomical units away, that's way too small to capture. And that's again something that modern telescopes, even amateur telescopes today, can do. In a sense. So it's not. But as far
Okay,
as
well, that makes very good sense to me. And we are right at the top of the hour,
we are,
where we must take a break. Ladies and gentlemen, this is Dark Matters Radio. Tonight, my guest, Mr. Marc Dantonio, joining us, as always, Mr. Mark Center as co-host. Gerry ran into technical difficulties tonight for whatever reason. He's back in Missouri. The internet evaporated or something. He couldn't
in his
join us.
misery in Missouri.
Yes, that too. But at any rate, we'll be back on the next hour. Stick around. We got a lot more coming.
Hold on to your seats, Cosmic Explorers. KGRA Digital Broadcasting, the unrivaled #1 source for raw, uncensored paranormal and UFO talk radio, has just unleashed a sizzling online merch store. Stay cosmic on the move with accessories, rugged phone cases, vibrant yoga mats, and notebooks perfect for jotting down UFO sightings. Ignite your obsession with the unexplained through bold, exclusive gear that demands attention. Kicking off with the Supernova, the store launches 2 heart-pounding collections, KGRA Digital Broadcasting and Bishop James Long. Every item you grab helps power the network and its groundbreaking shows. Stand with the truth seekers. Act fast, score your stellar swag, and join the uprising today.
MUFON is the voice of thousands of like-minded people who want to see change. We speak up against UFO secrecy. We engage governments and agencies around the world on the topic. We share information with the public through our journal, website, newsletter, social media, and even our own TV channel. When you join MUFON, you add your voice to the cause. Few things are more important in our time than understanding the UFO question. Join MUFON. Find your friends.
are back, and I see Mr. Gerry Kissel is still in misery because Missouri's got no internet. Mark,
Yeah.
Mark Center, have you checked on that?
I've been talking to him, and he said that the worst part about living in the country is when this kind of stuff goes down. So they just have to wait and see. I was wondering if Skywatcher can play that little video again that Mark put together, and in the middle of it, pause it where it turns green. Just pause it. If you can do that in whatever player you're using. Right there. I guess he can't. So it turning green, and you've already explained it. You could do it again if you want, but it turning green is a very, very expected cometary response. Yes?
Well, that green color on the whole frame was due to just a color mismatch on that particular photo. I just sent 2 more, which show the other night on the 5th, I think, in the morning of the 5th. You see it at one spot, and it's actually sharing the sky with an asteroid right next to it, which I submitted these 2 photos to you so you can see. You see where it started when I started photographing it and where it ended when I finished. You can see the distance it traveled was just immense. Just like a large distance over a course of like 40 minutes, in the sky. And so this green color was just a mismatch of the color process. Part of the problem was that there was a moon out at the time, and so I probably just neglected to color correct that particular frame.
That's fine. So they do change color though, right? Or wrong?
Well, the sky background, like that. Okay, that picture I think is that one is the one I think I just sent. It is. Okay, that is the final location for the night that I took it, and then the next one is where it started. So you see that bright star next to it right there?
Yep.
Just to its right?
Yep.
Okay. Now, to its left, okay, you see kind of, I'd say it's probably at the 8 o'clock, 8:40 position, 8:35, 8:45 position. There's another brightish star.
Yep.
Okay, that's actually an asteroid. Okay, that's an asteroid that's there in the same frame. And in the next photo, this is the first one, and then that one there, you can see now.
Oh yeah, it's much closer.
Yeah, it's moved obviously.
Mark, let me ask you this real quick. This is just a quick and dirty math equation in my head, but roughly every 10 hours or so, this thing travels 1 million miles. Would that be correct?
Well, if it's going 135,000 miles an hour, you multiply that by 10, right? Right. And so you're looking at, 1.3, right?
Well, then 1 million miles. Yeah, 1 million plus. Okay. All right. That's whipping along pretty nicely, I would say.
Yeah, but the thing is, it's also heading sort of in a direction that's going to take us closest to us. Like if you're looking at it at this angle, as it gets closer, the shortest distance is a straight line between these 2 points, perpendicular. So if it's out here, it's going to be a little further away, and then as it gets closer, that line gets shorter, right? And that line will get down to about 170 million miles. All right, 174 million miles at the time of closest approach on December 19th. So
explain to us, be it a comet, an asteroid, they may respond to this in a different way, but explain to us the forces of the sun and or planets or whatever to make these things break apart and just
You're talking about gravity, right?
Well, I don't know much. They didn't teach this in school, so I never took any classes in this. So
shame on your school.
Well, hey, so what?
It was up in the Bay Area, Mark. So that'll tell you a lot.
So
they were more concerned about tree preservation
tree hugging.
and
Yes. So if something the size, do we have a mass yet? Because we didn't have a.
Avi's research showed something like 33 billion tons, and obviously it lost a substantial amount of that as it went around the sun, at least a portion of it.
Right.
Because it evaporated a little bit. Now, there was an indication that it got much brighter as it went around the sun.
Right.
And the reason that could happen is something that was speculated, and that is that as it went around the sun, enough of it melted that it broke into fragments. Now, as it breaks into fragments, those are new fragments that each are going to give off more light and dust coming off, and so it would tend to brighten the overall picture for a period of time. And but not right, we can't see the nucleus. There's no telescope right now that's showing us what the nucleus of this thing looks like. Contrary to all the crap you see online, okay, there is no nucleus to this comet that you can see. You're not at this point. We saw the nuclei of a couple of comets, okay? The Jodo craft went to a comet, I think it was Halley's comet at some point, and we saw the nucleus of Halley's comet, but it was a very poor image. But then we had the Rosetta mission a few years ago that went to a comet which called 67P, otherwise known as Churyumov-Gerasimenko. I know you're all thinking of that.
Oh, hey, yeah.
Okay, but comet 67P, we landed on. Okay, the Rosetta probe orbited it and dropped the Philae lander, which went down. And when it hit, it was supposed to fire these projectiles into the surface to hold it there, because it was such a small comet that if it hit it like this, it would have bounced off and just kept going until the comet's gravity brought it back down, some time later, and it would have just kept bouncing and bouncing, because if you pushed off with your feet, you would have escaped from the comet. You would have had enough escape velocity with the muscles in your quadriceps to push you off the comet. Okay, but Philae, the Philae lander ended up getting lodged in a crevice. It bounced they say 15 times or something. Bounced, and the firing thing didn't work. They couldn't, or when they fired it, it shot it and made it bounce off. They couldn't penetrate it. I don't know what it was, but so the comet had very low gravity, right? So
remember the lowest bidder, Mark.
Huh?
Oh, the lowest bidder.
Okay, well, but the fact was that's one of the nuclei, one of the cometary cores we've actually seen the best of. In fact, I use it in a lot of my talks because it's just a beautiful vista, and in that, one of the things you can see is that there's streaks coming off of it. Now, those aren't cosmic rays. They aren't things that are not supposed to be there. Those are jets of material shooting off the comet, okay? And these jets are something very common with comets, okay? Trapped material inside the comet's icy, surface. When it gets liberated, it shoots a little dust out, and the gas trapped inside goes and shoots out. And when it does that, it causes the comet to shift in its orbit a little bit. That's a term. The term for that is called non-gravitational acceleration, which you've probably heard with 3i Atlas. They said, oh, it's not showing non-gravitational acceleration. That's because the jets it was sending out weren't powerful enough to move it a substantial amount because the comet was more massive than we're used to. So that's where the estimate of 33 billion tons came from. There's no way to really measure that.
That's a hell of a lot of weight.
It is 33 billion tons of material, if it's accurate. However, after it went around the sun, we did see a lot more non-gravitational acceleration, a lot more jets driving it around and moving it. Okay, so comets don't just go, they go like this. They move in their orbit because they're propelling themselves around with their little jets of motion that are created by their own outbursts that they produce. And those outbursts are the things that we're used to seeing with comets. And with this one, we didn't really see those initially. Now, part of the reason for that could have been that this comet sealed for billions of years with carbon dioxide ice, took some time for that carbon dioxide to sublimate off. And when it did, maybe that's why we saw a tremendous amount of carbon dioxide around this object. And then as it got closer to the sun, it started to melt enough that trapped gas within all of that could shoot out and create these little jets. Okay. And those jets are the things that, we look for in comets and we expect to see in comets, because in our solar system, every comet we have that we've seen has this little additional little propulsive energy. It's like comet farts, right? I mean, they just like shoot off this dust and gas in all these directions based on the trapped material inside their crust. And as it melts away, opens up a little hole, whew, that stuff shoots out because it's basically getting released into a zero pressure area, right? Which is the area around the comet. And that's why comets have this glowing blob around their head, around the nucleus. That's why it doesn't look like the moon. Okay, there's a tiny rock in there or ice ball, and it's got this sometimes millions of miles in size cloud around it called a coma. And that coma or cloud, that's what the coma means. That coma is this cloud of released dust that's just hovering in the space around the comet and is sort of trailing behind the comet, but it keeps getting replenished as the comet moves along, and it stays behind and trails out and makes a tail of the dust tail, we call it, of the comet. So comets are very complex creatures, but they have a lot of carbon-based compounds. They have carbon dioxide, carbon monoxide. They have cyanogen, which is a carbon and a nitrogen molecule atom together, and in a pair, CN and CN. That's a cyanogen molecule. Yes, that's cyanide. And so we have that going on. We have water. We have carbon dioxide ice. We have ammonia ices. We have all kinds of chemistry on there, and possibly some. In this case, not sure yet, but we probably also have hydrocarbons on here as well that are frozen in time on this comet.
Well, Mark, early on in this story,
Yeah.
I heard speculation, or I read speculation on the possible age of this object.
Yeah.
And the one that sticks in my mind is this could be at least 7 billion years old, billion with a B.
Yeah.
Now that's true. That's older than our solar system.
By almost twice. Yeah, not quite twice,
Right.
Yeah. So
Do you give credence to that?
Oh, sure. I mean, there's no reason why it can't be. It's an interstellar object that could have been traveling between the stars for billions of years, and so if it's 7 billion years old, wish we could grab it and check it out, because the chemistry on this guy is probably going to show us what the early solar system was like. Again, wherever this was formed, there was a fully formed solar system it was probably formed in, and then it got ejected from its solar system for whatever reason. We've probably ejected thousands and thousands of comets over time, and it has to do with, a passing star causes a comet to go into the middle of its star and shoot out and get released from its star. It attains the escape velocity somehow and gets dragged out of its star system and makes this long journey to some other star system. When you've got nothing else around you out there, the slightest bit of gravity is going to tug on you. And so that slight tug could have taken you here. And I think that's kind of what happened with this.
So put your thinking cap on here. Let's say that we know how the building up generally of a comet is made and how it gets all the stuff around it. And then when it gets close to a sun or whatever, it starts to heat up and it starts to fragment and has its...
Excellent. Yep, you're right.
Then, knowing what you know, can you sort of overlay those sorts of known aspects onto a artificially built thing. Because if we're to believe 40%, then a similar thing is happening to a possibly artificially built thing, and this cometary type of stuff has glommed onto it. And as it goes around the sun, it's kind of acting the same way as it's jettisoning this stuff off, but it's not a little ice ball or whatever. It's an artificial made out of whatever, dilithium crystals or whatever. Does that play to you at all, that it's acting as one, but it could actually be something overlaid onto something artificially made?
Well, you know what? I mean, it would be arrogant to say absolutely not.
Well, I'm not asking for that. I'm just saying, your best kind of, seems a little far-fetched, or I don't know.
Well, here's a thought. E.T. is out there. They saw this object, and they said, boy, that'd be a great platform to put some of our nanoprobes on and let our nanoprobes do their thing. And before you know it, voila!
Well, you wouldn't put nanoprobes on the outside. It would have to go on the inside, because they just get...
Hey, they're nanoprobes. They can do whatever they want.
I'll just let you two argue about this.
No, hey, I love a good probing. I'm the first guy to say it.
All right, you know what? Okay, now I'm going to leave.
I mean, I'm from the Bay Area, so...
Oh my God, that's just like so wrong on every count. All right, so as far as what you asked, okay.
Yep.
Is it possible this is an alien craft that has just accumulated a bunch of stuff after it's gone long defunct? I can't say no.
Right.
Okay, I can't say no to that. For that matter, maybe Borisov was, maybe Oumuamua was, for all we know. But that's only because they were interstellar. Because we don't expect to see that kind of activity from within our solar system, within the group of cometary debris or asteroid debris.
An indigenous cometary debris.
I guess you would call it indigenous, yeah. as opposed to native. So, but that said, I think that in this particular case, I call a duck a duck. I mean, it looks like a comet, something that we see naturally here. Now, when one of the arguments was, well, it's shedding nickel, and we might coat the outside of a spacecraft with nickel. You got to wonder, is that true? Would we? Nickel's heavy.
Yeah.
We would coat it with a much lighter material, and so it would not seem to be a very effective coating to put on a spacecraft, but or iron, right? Iron has too many problems, too much corrosion can occur, breakdown in the interstellar medium, so I wouldn't use iron, and I probably wouldn't use nickel for the same reason. But
right.
But that's just me. But the fact
what about chrome?
Chrome? I don't use Chrome. I use Firefox. Anyway, sorry, I had to do that.
That's the same thing I do. Yeah,
I know. I'm such a jerk. I apologize. But no, Chrome would be, of course, highly reflective. But what's the point?
Yeah. I mean, it's not very.
Well, I can give you a rundown on why they used chrome in the M16 rifle if you're interested. But hey,
well, that's for shooting in the air. It's shooting in air, not in a vacuum.
Right.
So.
And chrome does not stand up well against the elements. It just doesn't.
It tarnishes, and you get all kinds of debris on the chrome, and microscopic abrasions and stuff occur in the surface.
Not if you perform your daily maintenance.
Well, okay.
That's something else.
A 33 billion ton spacecraft would require a lot of maintenance, But let's look at this though from a different perspective. This object is single-handedly garnering a lot of attention because of the fact that people are starting to look up more and are starting to have a conscious view that maybe there's something else out there besides us. And when you look at David Grush and you look at some of the other people that are whistleblowers, okay, I've been told I might be testifying in Congress. No date set, but I've been told I might be. So that said, there's a lot going on in the universe that merits some attention, and a lot of people are taking note of it, and that's actually really good for science.
It's the new shiny thing, though, because in the 90s, we had this exact same thing happen at a lower rate with the flap over Mexico, right? And all of those interesting things that we're seeing, and everybody started looking up, and they were taking their camcorders and shooting the videos and all that. I think it's just the shiny thing still. I mean,
it could be, but it's the new shiny thing.
Yeah.
It's something that some of our brighter minds on the planet have attached themselves to and said this could be something important. And that's something that didn't happen with the flap over Mexico.
No, that's true, especially now that they look at this and go, I think there may be some security money involved here.
Yeah, I mean, we're never going to be able to divorce ourselves from the people that are going to try and make a profit from almost anything. Remember, never let a good crisis go to waste, right?
Right.
So you're going to always have that. But it's not only the current day when that happened, because in 2 passages of Halley's Comet ago, right, in the 1800s, there was an astronomer named Flammarion. And when Comet Halley was coming through, they were able to look at Comet Halley and see that it was green. And Flammarion correctly deduced that was due to cyanogen, a derivative of cyanide. And he said it's possible that if Earth flew through the tail of the comet, that cyanogen could possibly pose health risks. And just like today, we have Avi Loeb saying it's possible that this thing could be an extraterrestrial intelligent craft. And then the internet gets legs and starts taking that, and now suddenly it's the doomsday weapon from Star Trek, or it's something else, and it's a spacecraft, and it's making a turn toward Earth. Oh no. In Flammarion's day, they didn't have the internet. What they had was newspapers and people giving talks. And even though Flammarion didn't intend to inflame people, he ended up inflaming people.
Sure.
But then you had the ones that always wanted to make a buck, and they started selling comet pills. Take one of these comet pills, and the comet cyanide will not kill you or your family. Buy enough for the whole family and all your friends. So they sold comet pills, which were basically sugar pills. So again, never let a good crisis go to waste.
Well, Mark, on Thursday, this past Thursday, on UAP Crossfire, heard right here on KGRA.
Indeed.
UAP Crossfire begins at 5 p.m. Pacific, 8 Eastern time on Thursday. But we had a fascinating show with a guest that basically said that there is a tremendous PSYOPs campaign going on with this 3i Atlas situation. Now, having been involved with military intelligence in Southeast Asia during the Vietnam War, which I was, I got to say that rather resonated with me. This would be another case of don't let anything good go by and not take advantage of it.
Yep, absolutely.
Now, what do you think about the possibility that there's a lot of PSYOPs being done with this 3i Atlas thing?
Well, one thing I do know that's being done, factually, is something that will be mistaken as a PSYOP, but is not. Okay, I know this. Because this is the third interstellar object, the governmental communities and the agencies have realized that this could be a real threat to our planet. So they're going to use 3i Atlas as what's called a live fire test of a communication system between all these different entities around the planet to be able to see if they can make a clearinghouse of information to very quickly have a decision tree in place to do what they have to do with an interloper that could pose a threat.
Like an earthquake early warning system or whatever.
Effectively, but for asteroids that could kill the planet.
Right.
Yeah, exactly. And so the Atlas program is primary in there because it's going to end up with more telescopes around the world. And so this early warning system would be very important. And
okay, let's cut to the chase on that. Okay, I understand entirely what you're saying.
Okay.
But for the sake of this discussion, let us say, for whatever reason, this thing suddenly proved that it could be a threat to Earth. Realistically, come on, guys, there's not a damn thing we could do about it.
Well, of course not.
That's correct.
Right.
We don't have anything in place. I mean, the Dual Asteroid Rendezvous project showed that we could divert an asteroid
of size,
and it could divert 3i Atlas to some extent.
Right.
We don't know how much, but the key there is we need time and distance, most importantly.
Right.
We would have to do the diversion while it was still way the hell out in our solar system, which means we have to have the capability to find it very early.
Right.
And deduce its path very early.
And send Bruce Willis out there early.
Exactly. And with Clint Eastwood and
That's
a few other folks, and then leave Bruce on the asteroid to take care of it. Yeah. But the point being that system doesn't exist yet. It does, but Atlas is only, as I said, 3i Atlas is the live fire test for an actual emergency threat to the planet. And so that will be taken and people will run with it and say, look, see, it's all a psyop. It's really a threat to the planet. They're just not telling us. But in fact, it's not a threat to the planet. It's actually allowing us to test a system, a readiness test. Remember when you were in school, this is a test of the emergency broadcast.
Get under the desk.
And it would have the little thing on the TV, right? This was only a test. If this was a real emergency, blah, blah, blah.
Yeah, 20 megaton warhead, you're going to get under your desk, and that's going to save you, right?
Well, you'll just be flattened by the overpressure. But anyway, the point is that they're using this as a live fire test to get a communication network in place. And so far, it may very well be successful. I actually haven't heard. I can make some inquiries and find out. But the truth is that as a test, this is probably a good one.
Yes, I agree.
This is the third time in a few years that we've actually had an interstellar cosmic interloper. And it's not just interstellar objects. It's our own objects from the Kuiper Belt and from the Oort cloud that surrounds us as a globe of icy comets. Some of those out there are pretty darn massive, and they could end up on a path to strike us at some point in the future, and that's probably inevitable.
Well, hasn't it been basically surmised that over the last few 100,000 years, every roughly 20,000 years or so, something disturbs the Oort cloud and it sends a mass of debris into the inner solar system? Mark, hadn't that been surmised?
That's actually, it's not that easy because the stars...
I'm not asking if it's easy. Isn't that what has been theorized?
No, it's what people will say, but it's not true that it's on a schedule. In the same way that people say that geomagnetic reversal, the poles flip, okay? They say magnetic reversal, we're due for another one. Are we? If you look at the record, the geologic record, it's not periodic at all. well, we're 600,000 years overdue or 60,000 years overdue. No, we're not overdue. It just hasn't happened.
Which is like earthquakes,
It's
right?
like earthquakes, yeah,
Yeah,
and
yeah.
just like the eruption of the super volcanoes, right? Yellowstone. They say, well, the last eruption put 3 feet of ash in Nebraska, which it did. Okay, and we're overdue. But are we? I mean, there's yes, the plume of magma is only 2 miles beneath your feet when you're at Yellowstone. Scary, but and it's 100 miles deep. But the pressure is not something that we can say is building up and it's about to blow. Let's get our watches and we'll all watch. And that's not how it goes, and that's not what happens. In fact, the in that particular case, the crust is moving across this hot spot, which has the plume of magma. Here's the crust. Okay, here's Yellowstone. Okay, and the tectonic plates moving across it like this, so the hot spot stays there. Okay, and so you can see the old caldera where Yellowstone was, and then you see the new one. Okay, and you can see a line of them, just like when we look on the ocean floor, we see the hydrothermal vents. There's new ones, and then there's a chain of extinct ones. Okay, and those are following the path that the plate currently had been passed, and there's a mantle plume coming up at that point and puts hot water from the fissures underneath the ocean floor up back into the water and causes this little oasis of life. But we can't predict anything like tectonic plate activity. We can predict. Okay, we can't predict when the next major supervolcano will occur. We can't predict when a comet will come in. And we can't say every 20,000 years there's a catastrophic collision because something.
Well, 20,000 in that ballpark.
There's no way to
not on the dot. But
well,
yeah.
Okay, we'll take that. Let's take that apart a little bit.
Now, what the speculation was, and I'm sure you're aware of this, is that we may have a massive object as the solar system bounces up and down, which what ours does, right, Mark? It goes up and down.
I imagine you're talking about the sun.
Yeah, whatever.
The sun
it goes
is making little motions. Yeah.
Okay. That there's an object out there, perhaps speculation, a brown dwarf, and every so often, I'm not going to put a date on it, but every so often we get close to that massive object, which, by the way, we have not yet seen, but it's theorized it may be there. And that is what disturbs the Oort cloud, which then pushes that debris into the inner solar system.
Okay, I mean, if you're calling it speculation, all I can say is, okay, that's speculative. I mean, there's no...
Well, you've never heard that before?
Oh, I've heard that many times, but the fact is, I don't consider it factual at this point because we don't have a record of factual data. And
well, our human history only goes back 6,000 years.
Yeah, but we got the fossil record, and the fossil record tells us that there haven't been catastrophic impacts like that for millions of years. And the thing that is
that's not true.
Yeah, it is.
No.
65 million years ago, we had a catastrophic.
Well, we had the extinction of the dinosaurs. Yeah. But we've had a lot of other ones, not perhaps as big as that.
There was an impact in Greenland. There was a new crater found there. Obviously, the
Tunguska event, whatever that was. Yeah, the Younger Dryas event.
Dryas, yep. Like Syria or Jordan, Yeah.
Which wiped out a lot of stuff.
Yeah, it wiped out some, but it wasn't a planet killer.
All the megafauna in North America it wiped out.
The what?
The megafauna. Great woolly mammoths, Columbian mammoths, giant diurnal wolves, giant ground sloths, et cetera, et cetera.
That's up for debate, actually. That's
I don't think.
Yeah, they don't say that the Younger Dryas event killed woolly mammoths. But
something did.
It did. That's right. And among the things that happened was the break of the ice dam at the Mediterranean, which actually caused a massive flood which wiped out a lot of creatures at that time.
Well, I gotta tell you this. My grandfather, my mother's dad, his oldest brother, okay, Uncle Charles,
Wasn't
was
around
actually a
younger
great uncle.
Giles.
Subscribed to National Geographic magazine from almost the beginning of the
For the
20th
articles,
century.
not the pictures. For the articles.
I got a stack of those things. And,
Well, he died in about 1958 or 59, and his wife sold for $5 all those National Geographics to my dad.
well,
Now, as a kid, man, I plowed through
Yeah.
treasure troves. I know. We find all the native women and stuff.
And
Yes, I know.
well, no, I'm not talking about the native boobs. There was an article in there in Siberia from Russia. They were communists then, of course, but they found a giant, massive, unimaginable boneyard of giant woolly mammoth carcasses and bones.
Yep.
As if, and the way it was described in the article, as if an angry god slammed his hand down there and propelled them through the air. They theorized that winds of roughly 1,000 miles an hour picked up all those animals and smashed them into a million pieces. And we're talking about tens of thousands or more of these giant animals. Now, where in the hell does 1,000-mile-an-hour wind come from? Well, the only thing I could think of, and Mark, please, if you can think of something else, let me know, some type of astronomical impact.
That could certainly do it, I would imagine, but you would also see evidence of high temperature artifacts on the bones. You would also, but if you didn't, the other thing that could cause it is a massive catastrophic flood. And so perhaps they were just swept along and battered by rocks and everything in a potential.
Now, some of those animals, though, and I'm sure you're aware of this too, they found them literally flash frozen with buttercups still in their mouths, undigested vegetation in their stomachs, flash frozen, as if somebody opened up a door and threw them into zero temp and shut the door, and boom, you had a popsicle there. Now, that was strange. As a matter of fact, some of those animals, and this was the part that I found fascinating, the people that found those cut chunks of meat off those animals, roasted them, they were still edible.
They were desperate.
Well, they might have been.
But see that I heard the flash frozen thing, and that was actually more evidence of the flood rather than a cosmic high temperature impact. So it's just that obviously we were probably in a cooling period at that point anyway. So when you get hit by a wall of water and you've got buttercups in your mouth and you get propelled at high speed, maybe you hold them in your mouth. I don't know. I mean, it's hard to tell, but when you stop, you undoubtedly are going to end up getting refrozen. And many times, well, in an avalanche, when climbers are in an avalanche, people say, well, why don't they just climb out? It's because what happens is the ice is liquefied effectively. It's liquefaction, right, as it comes down. But as soon as it stops moving, it's like concrete and it cements you right in. And effectively, you're flash frozen in place there. So maybe there was a wall of icy froth that they were caught up in that did that to them.
That's why I never go anywhere where they can have avalanches, ever.
I think that's probably wise. I'm not interested in those. Or rock slides.
So before the end of this, I want to read you guys a quick thing. This is from a Facebook group called What the Fact, FACT. Journey beyond the stars with mind-expanding facts, cosmic wonders, and the latest in space science. From black holes to galaxies, we explore it all. Follow What the Fact to unlock the secrets of the cosmos. I sent you guys approximately 40 of the memes that these guys pollute the internet with, right? And much like flat Earth and not going to the moon, et cetera, I probably take it more personal than I should. I'm not an educator, but if I was an educator, I'd take it very personal that this horse shit is just being ramped up out there to the point of it's turned into a comedy. I mean, I look at this and I know that if we have people who believe the earth is flat in 2025 by the thousands, then when they see stuff like this, it's not a good thing. Maybe not for humanity as a whole, but it's not a good thing, right? To educate these people on stuff that's just horse shit. Now, I sent a couple of my favorites to Skywatcher. I know Gerry did. I don't think that you guys did, but
I did start looking at the link, but I didn't see your meme. So,
yeah, I sent you a zip file with 40 memes in it.
I didn't get to look at it, but maybe Bill can throw them up.
Hey, Skywatcher, are you out there? Okay, here's one. Massive deep space giant targets 3-eye atlas as scientists warn of alarming purposeful movement. And this is what they say that it looks like. Next one, please. A space seaman. Voyager 2 transmits shocking deep space discovery immediately declassified by NASA, leaving scientists and the entire world speechless. Next one. We're not going to play them all. Hubble reveals striking deep space view of interstellar comet 3-eye atlas with unusual dust motion. And the last one by Gerry. Dung beetles become first insects ever proven to navigate by watching the stars in the Milky Way. Now, look.
Maybe that last one had a little bit of credence potentially. The previous one before that was the Star Trek Doomsday Weapon.
Yes.
Show thing.
Look, I have some critical thinking. Okay, I know not to put my hand into the sink and turn on the grinder, etc. I know. I wear earplugs when I'm grinding and stuff. I wear stuff on the eyes. It saddens me that this kind of horse shit is out there for the clicks and the views, but the bigger picture is somebody like you, Marc Dantonio, are out there doing good work, and you have people following you, and you're successful, and yet there's a huge swath that you may not even care about, but there's a huge swath of people out there who are just... I'm surprised they can breathe on their own, and they're reading this stuff and they're running with it.
Look, I gotta say one thing, and I know this is gonna sound a little bit crude, but on this show, I think it'll be okay.
What do you mean by that?
A bullshit? A bullshit? A bullshit.
What I mean by that is, I think there's an awful lot of people out there that got their degrees on Google and think that they have real degrees. And they will sit there and tell you things that they will claim are real. And when you tell them the facts, they just negate you and say, you don't know what you're talking about. You don't have any idea how many times I've come up against this. And I basically say to them, I didn't get my degree on YouTube. I didn't get my degree on Google. You did. So just shut the F up because you're wrong. I mean, and that's the only time when I'll actually, use that kind of thing is when people start saying that, these kinds of things that really come from only watching someone else's YouTube video.
Right.
Okay.
Right.
doesn't fly with me. You either have the research background or you don't. And this is where I agree with Avi when he basically says, I wrote 9 research papers on 3i Atlas. I mean, he did. He did the work, and he deserves the credit for it. And when people go after him, I can see why he gets angry. I mean, I do. But I basically, most people who know me know that I don't have an ego to bruise. I'm not going to, be egomaniacal about any of this stuff.
Right.
I'm not arrogant about it. But I do know what I do know.
Yeah, you did. Yeah.
And those things I don't apologize for, right? And so if you try to say something that's a blatant lie, like we didn't go to the moon, okay, I will call you a liar, and I will.
But here's something that I
don't say.
Let me take a page from Robert Heinlein's book, A Stranger in a Strange Land. Okay. I don't grok the fact that Avi Loeb would put, except for maybe harass, Kim Kardashian on his research team, and here's a chick that doesn't believe we went to the moon. Mm-hmm. Now, maybe I'm missing something. Mark Center, am I missing something?
But I can only say that it has something to do with he's had his face in books his entire life, right? He's been deeply into study, deeply into theory, deeply into high math and all that. And he's getting some attention possibly he's never gotten before. And maybe he's just a nice guy. And she reached out to him and said, I find what you're doing fascinating. And, it may only be that. I don't understand why he would do that as well. I don't understand. The bigger picture is this. You should, in my mind, you should never put a percentage on your prediction. I'm not a big fan of that, of unknowns. You shouldn't do that. It's 30%, it's 40%, it's 80%. Generally, especially in science, and I'm a freaking moron, and I would never do something like that because I have nothing to back it up but assumptions, postulations, best guesses. And to some extent, it's kind of like the religious folk who say, well, we're going to have the ascension on September 21st or whatever, right? What you won't find are most of the well-educated religious scholars and stuff ever do that. They won't do that because it goes counter to their education and their training in the Bible and religion and like that, right? I would think that with Avi, it would go counter to his training to say, well, I'm going to give this a percentage of my prediction is going to get a percentage. I don't see any upside there.
Well, can I just explain? In astronomy, we have very little that we can say very, very definitively. And so we will often express a percentage for a certain, like for instance, all our measurements have error bars around them, plus or minus 5%, right?
Right.
Plus or minus 12%, 13.9%, 6%. Okay. Well, when you work within error bars all your life, you can't help but say that I'm going to put an error bar on my thoughts about the comet. So that's kind of where this comes from. Now, on his scale from 0 to 10, I think at one point he said it was a scale of 6%, meaning 60% rather, saying that he was a little more than half convinced that this was probably alien. Now, it would have been sufficient for him to say I'm a little bit more than half convinced, but he put a number because we're used to assigning uncertainties to all of our observations, all of them. Okay, that's just the way it is. You have to have uncertainties on everything you do.
Well, before these three things came in, did he have these same sorts of views on aliens in general? Because I'm unaware that he would come out and be on the Hoagland show or something and talk about this stuff.
I think that it was sort of, I don't know, but I think that in his case, from what I see, he's always had a thought that life might be, maybe he has my book.
Right.
I don't know. Okay. But I always thought that he was on the side of there's life out there, and I think it may actually be here in a certain way. Now, you guys know I talk about interdimensional travel, right? Well, I don't say that's exactly how it works, but I have like a sort of an uncertainty with it, right?
Right.
Well, but I do say that I think that's the only way that they could be here is by using interdimensional capabilities. And a little over a year ago, Avi came out and said, I think that aliens may travel interdimensionally. And I've been talking about it for 5 years. So
Right.
clearly, either he has seen stuff I've done or he's come to this conclusion himself, which either way is fine.
Well, I need your prediction with math attached to it. What's your percentage? 60%?
On this thing?
80%? On the way they travel.
Oh, on the way they travel. Okay, well, I think that based on all the stories, and again, we have percentages of uncertainty for every single UFO case out there, right? But based on the fact that we make these assumptions, we say, okay, we have givens as well, given that the likelihood that they're here is, let's say, 100%. Okay. How could they get here? The only way they could get here in a timely fashion requires, in my view, an 80% certainty that they're using interdimensional travel.
Right. That makes sense. Yes.
Yeah. Well, that's what we're talking about here. And so, if they're possibly here, possibly not, that means 50%, right?
Right.
Maybe they're here, maybe they're not. Well, that's 50%. It doesn't mean 60-40. It means 50-50. Maybe they're here, maybe they're not. That's a 50% thing without stating the number. Okay. So if it's 50-50, well, then in the case where they are here, then it's still 80% that they're probably using interdimensional travel. And if they're not here, well, then they're not using it at all.
Right.
Okay. So it goes from 80 to 0. So that means it's overall a 40% chance possibly that they could get here at all. Considering the 50-50 nature. Right. It gets so convoluted, but the point I'm making is that in the universe, when we're talking about astronomical observations, we always observe with uncertainty. We don't have specifics except in certain cases. The spectra of a star is the spectra of a star. When we get the Fraunhofer lines, the lines of absorption lines in the spectrum of our star showing what it's made of, okay, we know those with certainty. We can say those belong where they do. We have the locations in the spectrum where they belong. They're always in the same place, okay, because we're never moving toward the sun or away from the sun at any kind of speed that would make them shift using what's called Doppler shifting, okay, of the lines. So that's certainty. We know certainties about something.
Well, guys, I hate to be the one to break in here and let you know, but bottom line is we've got under a minute before we've got to shut down.
What's Marc Dantonio got going on? What do you got going on?
Well, I'm going to be streaming in a little while from Benson, Arizona, I believe.
Nice.
Oh, cool.
Yeah,
I'm going to stream too when I go to the bathroom. It's a different stream, but
I just want to come on down. You asked, I don't know what's going on. Kentucky Skywatcher said he invited her as a joke. He thought that since NASA answered her questions, but not his, that maybe they would talk to him with her on the team. It was a joke.
Now that makes sense.
There you go.
That makes sense.
Well, I don't like that.
NASA, never a straight answer. NASA. Hey guys, that's got to be it for tonight. Look,
NASA,
Marc Dantonio. Marc Dantonio, I hope you and yours have the greatest holiday ever. Coming up in just 2.5 weeks or so.
Thank you very much. Good to see you guys. Thank you so much.
And thank you so much for coming on tonight and elucidating us. I feel elucidated.
You do?
With additional 3i Atlas material.
You're elucidated.
Mark Center.
He's hallucinated.
I handbrake Nuremberg. That's in my future.
Okay.
And that's it, gang. Hey, UAP Crossfire, Thursday, 5 p.m. Pacific time, 8 Eastern. Be there or be square.
Great
and
show.
God willing, the river don't rise. We'll see you next week. Good night, everybody.
God bless Sam and Dean Winchester.